Now let's look at solving a system of linear equations in two variables by the method of elimination. Some books call this addition, but it's the same thing. All right, operations that produce equivalent systems. So a system of linear equations is transformed into an equivalent system if you do any of these things. The two equations are interchanged. In other words, the first equation becomes the second equation, or the second equation becomes the first equation. Okay, also, there are equivalent systems if an equation is multiplied by a non-zero constant. And that's due to the multiplication property of equality. If you multiply an equation by the same number on both sides, you don't change the equation. So if you do that to one of the equations in a system, as long as it's non-zero, then it doesn't change it. It produces an equivalent system. And the third thing that you can do to produce an equivalent system, a constant multiple of one equation is added to another equation. So we're going to see that in just a moment. Let's go look at some examples. So number one, solve the system by elimination. I have 5x minus 2y equals 12 and 2x plus 3y equals 1. I'm going to get rid of that bracket so I can have a little bit more room to work. I want to have the same number but opposite signs in front of the y's. So a common multiple between 2 and 3 is 6. If I were to multiply the top equation by 3, I would get 15x minus 6y equals 36. If I multiply the bottom equation by 2, I get 4x plus 6y equals 2. Don't forget when you're distributing that you also distribute to the right-hand side of the equal sign. Okay, now if I add those two equations together, what is 15x plus 4x? That's 19x. Negative 6y plus 6y, that's eliminated. That's why we're doing this process, is so we can eliminate one of the variables. 36 plus 2 is 38. To isolate the x, if I divide both sides by 19, I get x equals 2. I'm not finished. I'm only halfway there. I need to plug that 2 back into one of the top two equations. I'm going to plug it into the first one because it's there. Okay, so if I have 5 times 2 minus 2y equals 12, 10 minus 2y equals 12. I'm trying to get the y by itself. Subtract 10 minus 2y equals 2. Divide by negative 2. So I end up with y equals negative 1. What is my answer? My answer is the ordered pair 2, negative 1. I apologize. The rest of the problems on the page, I had copied and pasted number 1, so I didn't have to redo the format, and I never went back and changed numbers. So if you will write a new number 2 as 3x minus 2y equals 8, and 2x plus 5y equals negative 1. If you print it off after I posted this lecture video, just ignore what I just said. Your problem is correct. So here we go. I need to eliminate one of the variables. We can choose the x or the y. I'm going to eliminate eeny, meeny, miny, mo. Let's get rid of the x's. Okay, the first equation has a 3. The second has a 2. The least common multiple between the two is 6. So to get the top equation to say 6x, I need to multiply everything by 2. 6x minus 4y equals 16. Also wanted to mention, if I'm going too fast, you're watching videos. You can push pause and try to catch up and think through as you're writing. Okay, the second equation, I need to get the bottom equation to say negative 6x. So I'm going to multiply it by negative 3. Negative 3 times 2x is negative 6x. Negative 3 times 5y is negative 15y. And that's going to equal negative 3 times negative 1 is 3. 6x minus 6x, that's gone. Negative 4y minus 15y is negative 19y. And that equals 16 plus 3 is 19. Dividing both sides by negative 19, y will equal negative 1. I get to plug negative 1 in for y on either of those equations. I'm going to plug it in right there. So I get 2x plus 5 times negative 1 equals negative 1. 2x minus 5 equals negative 1. Add 5 to both sides. I have 2x equals 4, negative 1 plus 5. Dividing both sides by 2, I get x equals 2. So my solution, don't forget it's x comma y. My solution will be 2 comma negative 1. For number 3, again, if you have an older version of the handout, go fix the problem. 2x plus 6y equals negative 3. X plus 3y equals 2. I'm going to choose to eliminate the x's. The common multiple between 2 and 1 is 2, so I'm going to leave that top equation alone. Not in red, sorry, those are answers. So I have 2x plus 6y equals negative 3. And on the bottom equation, I want a negative 2x out there. Hold on. Okay. To get negative 2x, I need to multiply that bottom equation by negative 2. Negative 2x minus 6y equals negative 2 times 2 is negative 4. Okay, my x's canceled. They were eliminated, and that was my goal. But my y's also eliminate. So on the left-hand side of the equal sign, I'm left with 0. Negative 3 minus 4 is negative 7. We've seen this happen before. If we get two numbers are equal and they're not equal, then our answer to the system is no solution. Okay, one last example with solving by elimination. If your problem looks different than number 4, go ahead and fix it. Okay, I'm going to choose to eliminate the y's this time on number 4. If I eliminate the y's, I need to get a negative 6 and a positive 6 because the least common multiple between 3 and 6 is 6. That second equation is good as is. 2x minus 6y equals 8. The top equation, I need to turn negative 3y into a positive 6y, so I'm going to multiply everything by a negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 3y is positive 6y. Negative 2 times 4 is negative 8. What's been eliminated? Well, the 6y minus 6y, that's what I was going after. That was eliminated, but negative 2x plus 2x is also eliminated. So on the left-hand side, I get 0. On the right-hand side, negative 8 plus 8 is also 0. Then I say, okay, is 0 equal to 0? Yes. So there must be infinitely many solutions. Okay, if you have an older version of the notes of the printout, I did not leave room for you to work this problem, so you may want to do it on the back of these notes. But let's go look at two examples with applications. First example says, Dennis wants to use cottage cheese and yogurt to increase the amount of protein and calcium in his diet. An ounce of cottage cheese contains 3 grams of protein, 15 milligrams of calcium. An ounce of yogurt contains 1 gram of protein and 41 milligrams of calcium. How many ounces of cottage cheese and yogurt should Dennis eat each day to provide exactly 62 grams of protein and 760 milligrams of calcium? I don't know about you, that's a lot of words and my eyes are crossing. Let's take it, read it again and take it slow. First thing I want to go after is, what am I trying to find? How many ounces of cottage cheese and yogurt? So there are my variables. X equals number of ounces of cottage cheese. And let's let Y equal number of ounces of yogurt. Okay, how many ounces of each should he eat to provide exactly, okay, I'm going to use a different color, 62 grams of protein. So let's go after protein. An ounce of cottage cheese contains 3 grams of protein. An ounce of yogurt contains 1 gram of protein. So I'm looking at an equation. 3 grams of protein per ounce of cottage cheese plus 1 gram of protein per ounce of yogurt. I need 62 grams of protein. Okay, let's go get the other information. I have to have exactly 760 milligrams of calcium. So an ounce of cottage cheese has 15 milligrams of calcium, and an ounce of yogurt contains 41 milligrams of calcium. So there's my second equation. 15 milligrams of calcium per ounce of cottage cheese, 41 milligrams of calcium per ounce of yogurt will give me 760 milligrams of calcium. I now have a system to go solve. You have 3 ways to solve that system: graphing, substitution, or elimination. Because I see a 1y on the top equation, I'm going to choose to do it using substitution. So here we go. My top equation, if I substitute or find y, find it in terms of y. 3x plus y equals 62. Solve for y. Subtract 3x from both sides. I have y equals negative 3x plus 62. Now, on the second equation, instead of writing y, I'm going to write negative 3x plus 62. Here we go. 15x plus 41. I'm not going to write y. I'm going to write negative 3x plus 62. And that equals 760. All right. Distributing. 15x minus, what's 41 times 3? 123. And 41 times 62 is 2542. And that's supposed to equal 760. All right, combining like terms, what's 15x minus 123x? 15 minus 123 is negative 108. So I get negative 108x, and if I subtract 2542 from both sides, I'm going to get negative 108x equals, okay, what is 760 minus 2542? Negative 1782. All right, I'm almost there for the x's. Negative 108x equals negative 1782. Divide both sides by negative 108. So x will equal negative 1782 divided by negative 108. I get 16.5. So what was y again? Or sorry, x? X was the number of ounces of cottage cheese. Okay, but I'm only halfway finished. I've got to go find y now. So I'm going to plug that back into one of the two original equations, which this one is an equivalent equation. So I have y equals negative 3 times 16.5 plus 62. Negative 3 times 16.5 plus 62. I get 12.5. Now I'm finished. What are my answers? I need 16.5 ounces of cottage cheese. And I need 12.5 ounces of, what was y? Yogurt. All right, last topic. Break-even analysis. In a free market economy, the price of a product is determined by the relationship between supply and demand. So some of you have asked me, how is this applicable? Here we go, supply and demand. Suppliers are more willing to supply a product at higher prices. So when prices are high, the supply is high. If the relationship between price and supply is linear, then the graph of the price-supply equation is a line with a positive slope. On the other hand, consumers of a product are generally less willing to buy a product at higher prices. So when the price is high, the demand is low. If the relationship between price and demand is linear, the graph of the price-demand equation is a line with a negative slope. Okay, in a free competitive market, the price of a product tends to move toward what's called an equilibrium state. The price of a product tends to move toward an equilibrium state. In which the supply and the demand are equal. That common value of the supply and demand is called the equilibrium price. To find the equilibrium price, we solve the system consisting of the price supply and the price demand equations. All right, let's go look at an example. Okay, the example, at $2.13 per bushel, the annual supply for corn in the Midwest is 8.9 billion bushels, and the annual demand is 6.5 billion bushels. When the price falls to $1.50 per bushel, the annual supply decreases to 8.2 billion bushels, and the annual demand increases to 7.4 billion bushels. Assume that the price supply and the price demand equations are linear. The first part of this problem asks you to find the price supply equation. Okay, we're going to let little p be the price per pound. Okay, so we're defining our variables. Little p is going to be the price, sorry, not the price per pound, the price per bushel. And we're going to let our, let's let x be the quantity in billions of bushels. Okay, so I'm going to tell you we need to go get some points because it says to assume that the price supply equation is linear. So if I have x comma p, what are my price supply points going to be? And it was 213 per bushel. The supply is 8.9 billion. When the price falls to 1.5 per bushel, the supply is 8.2 billion bushels. Do you see the 2 points there? I'm going to have the point 2.13 comma 8.9, and I'm going to have the point 1.50 comma 8.2. I need to go find a line that goes through those 2 points. Now let's go after our points. So I want it in the form of x comma p. So x is the quantity in billions, so 8.9 billion bushels when the price is $2.13 per bushel. My second point for my price supply, I have 8.2 bushels when the price is 1.50 per bushel. Now let's find the line that goes through those 2 points. Okay, I need, first of all, to go get a slope. My slope is going to be the change in y over the change in x, 2.13 minus 1.50 over 8.9 minus 8.2. I'm going to go to my calculator to do that. Here comes a fraction. My numbers are 2.13 minus 1.50 over 8.9 minus 8.2. And I get 0.9. So my slope is 0.9. So now here comes the equation of my line. Do you remember point slope form? Y minus y1 equals m times x minus x1. So I'm going to use this point. Y minus 1.5 equals 0.9 times x minus 8.2. I'm going to solve for y equals. Oh, and my y is really a p. Let me go change that real quick. Well, I'll change it at the end. Okay, let's get y by itself. So if I distribute here, I get y minus 1.5 equals 0.9x minus, what is 0.9 times 8.2? 7.38. To get y by itself, I need to add 1.5. So I have y equals 0.9x and then negative 7.38 plus 1.5 is negative 5.88. That is my price supply equation. Now, instead of doing y, we're using p. So this should be p here. All right, now let's go after the demand, price demand equation. So back up to the problem. Let's go do peak. Let's see, at 213, the demand is 6.5 million bushels. And at 150, the demand is 7.4 billion bushels. So I have the points 6.5, comma 2.13. And I have the other point would be 7.4, comma 1.5. I need to go find the line that goes through those 2 points. So again, my slope is going to be 2.13 minus 1.50 over 6.5 minus 7.4. My slope is the fraction 2.13 minus 1.50 over 6.5 minus 7.4. My slope is negative 0.7. So my equation, y minus 2.3 equals negative 0.7 times x minus 6.5. You could have used either point. I just chose the first one. When I distribute, I get y minus 2.30 equals negative 0.7x. Now, what is negative 0.7 times negative 6.5? I get positive 4.55. Last step, add 2.30 to both sides, and I get y equals negative 0.7x. Okay, 4.55 plus 2.3 is 6.85. Now, instead of y equals, again, I wanted p equals. So my two equations, here they come. P equals 0.9x minus 5.88. What was it? 0.9x minus 5.88 and negative 0.7x plus 6.85. My next task is to find the equilibrium price. So we need to solve this system. I'm going to do it by elimination. I have a 1p on the top and a 1p on the bottom, so I'm going to multiply the second one by negative 1. Leaving the first equation alone, 0.9x minus 5.88, and multiplying the second equation by negative 1, I get negative p equals 0.7x minus 6.85. When I add those together, the p's cancel. I get 0 equals 0.9x plus 0.7x gives me 1.6x. Negative 5.88 minus 6.85 gives me negative 12.73. Okay, to solve for x, I'm going to add 12.73 to both sides, and I get 12.73 equals 1.6x. Dividing both sides by 1.6, I get x equals 12.73 divided by 1.6 is 7.95. Oops. Now that I have x, I need to go solve for p. So plugging it back into that bottom equation, I get p equals negative 0.7 times 7.956 plus 6.85. So p is, let's see, negative 0.7 times 7.956 and then plus 6.85. 1.2808. Now, what does this mean in terms of the problem? Let's go back up to what x and y were. X was the quantity in billions of bushels. So the equilibrium point or the equilibrium price is when you have 7.96 billion bushels. And that's when you're charging a price of, P was the price per bushel. So you're charging a price of 1.28 per bushel. The last thing to do is to graph the two equations and identify the equilibrium point, supply curve and demand curve. I'm going to go do this on the calculator. So I'm going to go graph those two equations there in purple. So here goes. Y equals 0.9x minus 5.88. My y2 is going to be negative 0.7x plus 6.85. I'm going to do a zoom 6 to start with. Okay, those are my two lines. Let me go to a picture, and I'm going to do, hold on. I'm going to do that one. I'm going to copy it, and then I'm going to go over to my here. And instead of that, I'm going to put in that graph. Okay, which one of the two is the supply or the demand equation? Which one has a positive slope? It looks like the supply has a slope of 0.9. Okay, so the supply equation is going to be in blue. It has a positive slope. This is the supply. The red will be the demand because it has a negative slope. And the equilibrium point is right here. And what was that value for the equilibrium? It should have been 7.96, 1.28. Now, on your calculator, you can go check and make sure that that's the point you get. Here we go. I'm going to show you the steps too. To find that point using your calculator, I'm going to hit second, calculate above the trace. I want to find the intersection, so I'm going to hit number 5. Okay, it asks you the first curve. I'm going to get a little bit closer to the actual point of intersection. I'm going to arrow to the right. Okay, I'm on the first curve. Hit enter. Now it's a flashing cursor on the second curve. And I know that seems silly, but if you're graphing more than just two things, you actually have to toggle between them and find the two curves you're talking about. I'm going to hit enter again. And now it tells me to guess. So I'm going to keep arrowing over and hit enter when I get close to that point. It tells me my point of intersection is 7.956, comma 1.2806. Is that what I got? 7.1. Yep, that's it. Okay, that is a application doing systems of equations in 2 variables. And now it's time for you to go practice some problems. Until next time, bye.